Hi, I'm Craig Ecclestone. I'm with AVA Educational Solutions, and I'm the product specialist. I've got a demonstration I'm doing right now. I'm going to do today on the CO2 sensor, which I think is kind of intriguing, and I think it's one that rates fairly high on the cool factor when you're doing it with your students, but it also can help maybe address some of the curricular outcomes and just basically get them interested in science. What I'm going to do is I'm going to take this little white substance, which happens to be baking soda, and I'm going to pour a little bit of vinegar on that. And what you're obviously going to see, I don't think there'll be any surprises. It'll be a little bit of a bubbly show here, something like a volcano, and no doubt there'll be something emitted, some gas that's emitted, and I'm going to try to capture that gas and see if we can measure it. So what I've got here is a bucket that's completely empty, as you can see. And I've got that beaker, as I said, with the baking soda that's in it. So what I'm going to do is I'm going to take my bucket and I'm going to place it here as such, like that. And I'm going to now take the baking soda and the vinegar, and I'm going to mix them. And there's my, all right. So now what I'm going to do is I'm going to mix that all up like that. I'm going to put that in here as such. Throw a little bit, no, that's probably good enough there. And so I've got my baking soda and we'll keep it there. So now I'm going to take the beaker out. But as I lift the beaker up, I'm going to make sure that I spill whatever gassy contents that might be inside that beaker. I'm not going to spill the vinegar, but I'm just going to pull it out, and I'm going to pour whatever gassy contents might be in there. Pour it out like that. Take it out, and there we go. All right, so I now have a bucket full of nothing or something. I'm not sure. Let's see if we can just test for it. So what I have, I'm just going to put the bucket down there for now. Okay, I've got a CO2 sensor, and I'm going to start just measuring the room CO2 levels, which probably it's a closed room here, and plus we just did a little bit of an experiment. We might have higher CO2 levels than normal, but let's just see what comes out. So I've got my CO2 connected. As you can see up there, it's connected. I've got plenty of power, and what I'm going to do is just bring this graph out like such, and now I'm going to plot CO2 against time. And so I just simply go like here, and I press start, and I'm recording the CO2 that's in the room now. It's higher than it would normally be. You know, early in the morning in the classroom, it's certainly going to be less than 1,000. Background outside in the field, it'll be closer to 400. I'm not sure what numbers you can see. I probably should have put some numbers out there. I'm going to display them, but we're just under 1,000 right now, which is not uncommon for an enclosed area like this. But let's just see. I'm going to move it around here. It seems to actually be a little bit lower over here, down here. And then I'm going to bring it back there. So I'm going to put it here, and now I'm going to bring my bucket back up. All right. So I've got my bucket. I've got my CO2 level now. It's reading about 940, heading towards 900. I've got my CO2 here, and I'm going to lift it up around here. I'm going to bring the CO2 sensor up over there, bring it down over here, and all around. And it seems to be pretty comfortable around about 940, and that popped up a little bit. But we're talking about parts per million, so that's 0.01%, there, right? So we're not talking about very, very high levels. How can I get that CO2 level to go up? Well, what I'm going to do is I'm going to take my bucket that's got whatever inside it, and I'm going to pour it right onto the CO2 level. Take a look at what happens to that graph. So I pour it like that, and I'm dumping it out. Nothing's happening right yet. Oh, so yeah. Oh, look at that. Look at that. Look at that. All right. So we went from 900 parts per million. Let's see if we can get more out of it. Yeah, and then it peaked all the way up to about 8,500 parts per million. So it's a considerable amount of CO2 gas was in there. And so what's interesting about this is it gets kids to think about what might be in the air. You know, it's very easy not to think about the actual components of the air, but when you can have an effect like that, visually you can't see it, but we can actually measure it. I think it does illustrate a fair bit of that concept that there is stuff in the air that we need to be cognizant of it. And there's also ways of, from that little experiment, what's one of the properties that we can talk about CO2? Well, one of the things is it's obviously heavier than air, because it didn't, when I raised the CO2 sensor, put the CO2 sensor above the bucket, I didn't measure it. So why was it, why is it heavier? We can actually look at the chemical formulas for CO2 and try to figure out if there's some reason why we can deduce why it's heavier. But it is interesting, and it's one of those, I say, one of those interesting demonstrations. Students always seem to, and teachers as well, when I demonstrate it, seem to really catch on to and really get some excited about probe technology. So in any event, that's all I have for now. Thank you very much.